A pleasant welcome to one and all present here. I am Vinod, working as an assistant professor in Department of Civil Engineering at KPR Institute of Engineering and Technology, Coimbatore. I have specialized in ME Structural Engineering. Today, I am going to present my paper entitled Study on Mechanical Properties of Cell Combating Concrete added with slag aggregate and recycle aggregate. I'm gonna give a short intro to my work and then I'm gonna share an experimental results followed by it. As there is an increase in the cost of normal course aggregate, it has forced a civil engineer to find out unsuitable alternatives to it. The use of recycled aggregate and artificial aggregate in concrete production prevents a great environmental benefits through saving by reducing the consumption of natural aggregates. It also solves the problem related with the storage, transportation, and dumping of construction and demolition waste and iron ore slag. Here I have used a special concrete SEC, where the SEC has an ability to flow under its own weight, completely filling formwork and achieving the full compaction, even in the presence of congested reinforcement. It does not require any vibrations for placing and compaction. The eliminating vibrating equipment improves the environment on and near the construction site. It reduces the exposure of workers to the noise and vibrations. The main objectives are follows is to identify the optimal usage level of recycle aggregate and slag aggregate in M30 SEC for an practical usage, and also identify the strength and durability parameters of specimens. And from that, the optimal specimen is being identified, and the fluxural behavior of a beam element is studied to identify the stress deformation, strain, load versus deflection curves, and ductility index and crack failure pattern for an optimal specimen. And also, I have studied an internal structure study for an optimal specimen using SEM-EDAX and XRD analysis. The framed methodology of further my work is this one. And next, I have done a gap analysis for this study. So far, the experiments I have carried out. The global demand for the sand and aggregate is being estimated over 12 billion tons per annum due to the rapid urbanization and industrialization. Thereby, increase in usage leads to the depletion of natural resources. And my project base idea is to usage of recycled aggregate, which is a construction and demolition based, and the steel slag and slag aggregate is a byproduct which is obtained from a steel manufacturing industry. Approximately 150 to 170 kgs of slag is being generated per ton of steel production. And my project goal is to identify the optimal usage level of recycled aggregate and slag aggregate in SEC for a practical usage. Through this project, the ecological benefits which have been obtained are the application of slag aggregate and recycled aggregate is acknowledged as a highly promising material and also reduce the impact of wastages which is being generated. At current state, the slag is reportedly used in laying of road surface and road base, in making of asphalt concrete, and as an aggregate in concrete. However, the large quantities of steel is being unutilized and being stockpiled in many countries. The challenges we have faced are the optimum replacements are not so high for recycling aggregate and slag aggregate as an coarse aggregate as 40% and 30%. The mix containing slag aggregate is lack in strength and durability characteristics with the recycling aggregate. The action yet to be performed are the many studies have shown that the slag can incorporate as a mineral admixtures and also as a replacement for finer and coarse aggregate and also as a partial replacement for cement. Due to the negative influence of the slag, the replacement ratios are not so high. The actions yet to be performed are the addition of construction demolition waste and the slag affects the physical and mechanical properties of concrete. Hence, a study is performed in SEC, which is rich in all the characteristics. Other than the strength test, the increasing study on durability test will lead to the positive way for using the slag in concrete. The growth we have obtained in this project are for the M30 grade of concrete by the 100% of replacement of recycled aggregate led to 29.44% of decrease in strength and the slag aggregate replacement to 32.8 to 88% of decrease in strength. From the result, the fairly optimum strength obtained as SEC containing recycled aggregate and slag aggregate as a combination of 40% each 20. The following are the test results which is being experimented over the concrete. They are compressive strength, split tensile strength, Young's modulus, fluxural strength of prism, and fluxural strength of the water absorption and solvability. Compared to the SEC reference mix, the SEC containing recycled aggregate and slag aggregate of combination of 40% of each 20 cause a fairly optimum strength close to the SEC reference mix. So hence I choose an optimum percentage of sample as a SEC containing recycling aggregate and slag aggregate as a combination of 40% of each 20. From the mechanical test, the optimum sample residues and the SEC reference mix are taken for the physiochemical characterizations and microscopic observations. At first, the SEM analysis is being carried out to study the amount of fine CHSL present in the material and the intertransition zone, that is a bond between the mortar and the aggregate, and the amount of pores present in the material, which is being analyzed under a different magnification and compared with the reference mixer. In this graph, we can compare the elemental composition of an SEC reference mix and SEC containing substitutions. Comparing in image, the SEC containing the substitutions have a higher level of silica fume and iron content due to the addition of slag aggregate, which is rich in iron ore slag. An XRD analysis is being carried out on the specimen to investigate the characterization of a mineral chemical formula and crystallographic structures. Here we have identified the chemical compound with the formula and its crystal structure. And beam model is being generated and analyzed in an ANSYS for the stress, strain, and deformation values, which is being compared to the experimental values. The following are the conclusions obtained based on the experimental work so far I have carried out. The higher the percentage of replacements, higher will be the decrease in geological properties such as its strength and durability characteristics. From the SEM and EDAX analysis, the inclusion of silica fume and slag aggregate leads to the production of additional CHSL, which helps to achieve the fast strength. But the existence of mineral composition is quite different from the reference composition. The XRD test shows the graphics and pattern list of a chemical compound with the crystal structures. The ductility index exhibits in a being are viable and offers a more resistance to the load applications. The value of ductility index are in an acceptable rate. The crack failure pattern is being analyzed for a beams, which is initially results in formation of fluctual cracks. Later, the further application of loads, which leads to the formation of shear cracks before the failure. The analytical model of an ANSYS further elaborate the stress, deformation, and strain to our perception, which shows the point of failure to be obtained, and the pattern is similar to the crack pattern, which is seen in a fractional test. And thank you guys for your patience for listening, and kindly comment your queries in chat box, and I will try to answer it. Thank you.